Okay, hi there again. I'm going to talk a bit about software unit testing and, well, what about it? And I think I have an agenda here, so let's see. It's going to be about unit testing, terminology around it, a bit about its structure, why we do it, how it's done, and we're also going to talk about testable code. What is testable code? And maybe also a bit about good code. Testable code might be good code. Well, let's see. So, moving on. This is the last picture of a spacecraft trying to land on the lunar surface. Well, a couple of years ago, year ago. And it is the last picture because just a few seconds after this, it just crashed down onto the surface. And the reason why it crashed was due to a software bug in the steering system of the spacecraft. And the engineers actually found out that, well, we can't. It was a braking system that didn't work, so they couldn't brake the spacecraft before it, well, when it closed down in the surface. So they actually rebooted the whole system, but it was too late when it got up. So bang, crashed due to a software bug. So it's these kind of events that we try to avoid, and maybe a bit of thorough unit testing might take us a bit on the road to avoid these last pictures. We'll talk about unit testing. And unit testing in essence would be to divide your code into units. So divide your code into testable units. And a unit here, that could be a file of code, could be a class in object-oriented programming, module containing functions, could also be. So we're talking about the units. And then we're going to write test code to test these units. So we're going to write additional code that executes the other code and makes it run. And we're going to sort of try it from various aspects. Does it work? What happens if I send in this argument and that argument? And so on. So this means that if you thought you were developing a lot of code before, well, now you're going to double it. So you develop the program you have, and then you develop the test code also. And that's basically not enough, because the test code in general could be sort of twice or three times as much as your original code, depending on the application type. So you should prepare yourself to write more code now when we go into this unit testing area. Each item or each unit that we're going to test, we want to test them isolated from the other units. So we need to find a way sort of to extract only this class and test it independently in isolation from all the other classes of our system. And that is important part, and we're going to talk about, well, some techniques to do that then. And finally, we're going to run all these tests in automatically. So it's going to be easy to run them, and we can run them again and again and again. So this is all about unit testing, and this is something you do as a programmer when you develop the original code, usually at the same time or slightly after or even slightly before, depending. So why should we do it? Well, the basic arguments why you do testing and why you do unit testing is that you want to find the problems early in the development cycle, and problems here being bugs and flaws in development from me as a programmer's perspective, or perhaps missing parts from the requirement specification. So, and another argument advantage of why we want to do this unit testing could be that the process of writing these tests and thinking of the core of the of how I'm going to use the code sort of well, it affects how the programmer actually writes the code. So often we could get, well, better code when thinking of how it's going to be done, used. So it's an argument, improved code by thinking of how to write the test. We have this argument, of course, that the cost of finding a bug. So it cost money to find a bug very late in the system. And when I find and correct a bug on the same time I find it, I correct it, well, it takes 5, 10, 15 minutes. If I release my code and the customer finds it, well, it's gonna take a couple of hours for the customer to find it, talk to my support division, goes to perhaps maintenance or something, go to the test department trying to isolate it, send it to me because, well, it's your Michael. Okay, I fix it, so it takes an hour now because I'm not sort of in it, so I need to start up everything. So it takes an hour to test. And then it's gonna go back all that way through the test department. They're gonna test it, going to the maintenance. They're gonna produce a new release. The support team perhaps is going to go out to the customer and install it. And you see how many hours this is, both ways, and compare that to find the bug directly, correct it in 1, 2, 5, 10 minutes. It's a lot of difference. So yeah, of course, cost and time should be one major sort of reason why we want to do tests in test and find problems as early as possible. Another argument why we should do unit test is that code, if we write our code without thinking of the tests, it can be difficult to test. It can be even impossible to test, because I write code in a sense that it's really, really hard to write unit test for it. So then when we sort of write the unit tests in the same time as we write our code, we get more testable code, because I write my code and I think, oh, can I test this? No, I can't test this. Okay, so how can I change my code to make it testable? So we produce testable code when we are in the focus of also writing our unit test. And that in general, I think, is a very good aspect, and it's a quality measures of what type of code you produces, if you do it more testable or not. At least I would say it like that. So it produced testable code. That is the really good thing, and unit testing really helps us do that. And if we sort of drive it, unit testing helps us produce better code. Yeah, maybe. Well, I would say that. Okay, so let's see some pros of unit testing. You need to think about how to use your code. It is not just write the code to fix a feature. You need to think about how are the test program. How should it use my code? What is the API? And that is usually a good thing, because I need to think about that before someone else is trying to use the API of my code. So maybe I could build a better API already from the scratch. this whole session about writing testable code, and well, it's a, let's say, maybe it's true then. The result is testable, and good code at least is better than code that is not so testable. I would say that, in general speaking. There are, when we talk about tests, there are, we could sort of lay, well, some are white box tests, some are black box test. So just short note on what this is. So black box testing is when we test code that we do not know how it looks like. And that is not unit testing. Unit testing is white box testing, where we test exactly the code, we know exactly how it looks like, and we try to test the whole code. So that is called white box testing. Okay, we can leave that. So, okay, getting warm about unit testing, hopefully. Let's continue to see some basic structure and, well, how to work with unit testing. So, well, let's consider an example. We have an application which is divided into classes. And these classes, I would say that each class should be a testable object. An object that we can focus on and do tests towards. Each class, test object, can have one or several test suites. So we do test suites that are aiming to test a specific test object class. Each test suite contains of a set of test cases. So there can be many test cases in each test suite. And each test case has one or more assertions. Assertion is a sort of a check that the value is as expected. And each test case should have at least one of those. And altogether, to make it run, we have a test runner that executes all or selected test suites, test cases, perhaps automatically, and provide a result showing what test cases passed or failed. Okay, so this is another image saying basically the same thing. That we have a test runner that executes all our test suites. Our test suites are focused on the test objects, and each test suite then contains a set of test cases, and each test case contains a set of assertions. This assertions then, that is, I said it a check to verify that some function method gets the expected result, and we need to verify that, check. We do an assertion, and if the assertion fails, well, then the test case fails. And it is important to do these assertions. If you would ask a test manager out there, he would say that, okay, you said you have a unit test, but I see no assertion, then there is no unit test. So it's an essential part of a test case. Here is an example of assertions. This is a Python class. It's a test game class, so it's a test class aimed at testing a game, which is the test object, so it's another class. And we have one test method here that at the bottom it's doing an assert. So it's asserting that a specific value is true because that is what I as a coder expect. And when it's true, the test case passes. If it's not true, the test case fails, and there is something I need to sort of correct in my real code. So let's sum it up again. We have some terms here. The unit tests, or the unit, the software unit that is, and software unit or / test object, that is the focus for the tests. And the tests are all made up of test cases, small test cases that test different parts of the test object. And all these test cases that are sort of aiming at the same test object, they make up a specific test suite. And the test runner executes the test suites. Okay, well, let's see some more on unit testing shortly. Okay, let's go. When we do tests, we want to do tests in isolation. And this means that each unit, each software unit, should be tested in isolation from all the other units in the software system. So if my unit is dependent on another software unit, when I do unit testing, I need to sort of remove that dependency and be able to test the unit in isolation. Isolation also means that each test case, each test method must be executed and be able to execute without dependency to all the other test methods. So you should in general don't build up a sequence of tests that I first test this, then that, and it should be in that order. You should try to avoid that. So one test case should be able to be run independently of all the other test cases. And that is a good thing, because if we have a large test bed with many test cases, we can actually the test runner can execute all our tests in parallel and sort of reducing the time it takes to test our system. So how do we do this test in isolation when we have a test unit, a class that is dependent on two other classes, and it can't really do its work without those? Well, then we try to write more test code. We try to replace those two real existing units by mock units. So we write extra code with some dummy classes and put them in, well, hiding the other real classes. And then our test unit is made to work with these mock classes or mock dummy classes. And then I sort of can focus my test on my unit without interfering with the other real units. But that means that I need to write more test code, more mock objects, just to be able to test these units in isolation. And that is the way that it's done. But yeah, that also means then that the test unit you have that has very much connections to other systems could be harder to test and could cost more to test, because you need to produce more material around it. So that is something to sort of consider when you write your code. Is this unit testable in a good sense, or can I do it even more testable to reduce my efforts in writing unit tests? It's a name, test doubles is a common name for the things I talked about. These mock objects, also known as fake stub, dummy, spy, test harness. It is extra test objects just to be able to test my code in isolation. So testable is a general name for that type of code, extra code I write. Another thing that we work with in unit test is test fixtures, and that is about setting up the test environment and tearing it down. So to be able to run a specific test case, sometimes we need to do some preparation work. We need to set up an environment. And if we have done it set up, we need to tear it down after, perhaps. So preparation and tear down, and executing the test case in the middle. And we call this fixtures that are supposed to prepare for a specific test situation. Perhaps initiate a database, create a file, read some configuration files before starting up, and so on. This setup is usually we can do one setup for a whole class. So that is a setup method for a whole test suite. Or we can do a setup only for, well, for each specific test case in a test suite. So that would be for a specific test method in a test class, I could have this setup method to be run. So that is about text fixtures, preparing for test cases. Code coverage is a good driving force behind wanting you to be good at unit tests. It produces a report when the test run runs the test, and it produces a report saying what lines of code did you test and what lines of code is untested. So at the end you will get a percentage figure saying, well, you have 70% of unit test of code coverage for your unit test here. So that is usually a driving force to trying to excel and reach 100% of unit testing with, well, reach 100% of code coverage with my units test. And that's a good driving force. But we should also remember that it is not the end goal is not to have a good code coverage. Working with code coverage is just the means to an end. It just helps us getting good testable code, and it helps us reviewing the parts of the code that is not testing so we can add it. But it's really fun to get 100% of code, but it is not needed. How much coverage should we have? Well, it depends on the situation, depends on what we are testing. All code is not testable with unit test. So let's just adapt some basic test strategy that we are trying to test everything that can break. Test things that can break. And try to test every execution path. So if you have an if and else, test both paths. If you have a argument that should be in a range, well, try to send in the argument both below and above the range and see what happens. Okay, so shall we summarize again? We have test suites with test cases that uses assertions to verify various aspects of our code. A test runner executes the test suites, and the tests are all done in isolation. Test fixtures, we use them to make it possible to run these tests in isolation. And code coverage is a metric on how much code, parts of the code that our unit test is covering. Okay. Let's talk a bit about testable code and how we could think about writing our code to make it more testable. And this part is about side effects. A side effect is some kind of operation. Let's say that you call a function, and this function changes the value of a global variable. Has changed the application state. The function has a side effect. It does more than only calculate producing a result and returning it. So that is a side effect. Some example of side effect should hereby be modifying a non-local variable, as I said, a global variable. Modifying a static local variable. A static local variable is a variable that keeps its value between function call. It could be modifying a mutable argument passed by reference. So if you pass an argument by reference and you change that argument within the function, and then it will keep its new state after the function is done. So the function does more than just returning a plain value. If we do I/O like databases files, well, then it's a side effect that sort of keeps its value. It's outside of the function. So side effect again. And of course, calling other side effects function will also be same thing. Okay, so a bit about this terminology that is related to when we work with side effects and try to avoid them though. So there is something called referential transparency, and that is basically an expression. Let's say it's if you can replace the call to the function with its responding value, if you can sort of just remove the function with that value, well, then it's said to have referential transparency of that code section. But to be able to do this, you need to have a very pure expression, so pure function, pure expression, that produces the same result for the same arguments. Always same result for the same arguments and no side effects. Then we can reach this referential transparency. And a pure function, as said, returns the same value for the same set of arguments sent to it, always. And it has no side effect. It does not change any state of the application. That would be called a pure function. And pure functions are easy to test with unit test. You will see, when you have pure functions, you feel, oh, really easy to test. But when you have functions that do side effects, you need to do more assertions and well, perhaps do some fixtures to prepare the value, the state of application first, then execute the test case, changing the state, and then asserting that the state has changed. It's a bit different. You get a different test code for it. Another term on the same subject here is a deterministic algorithm. And yes, it's also easier to test a deterministic algorithm than a non-deterministic algorithm. So if it's deterministic, given a particular input, so sending a set of arguments to a function, it will always produce the same result. But if it's non-deterministic, say you have a function that is dependent on some outside value, perhaps the time or date that will change each time, well, then you have a non-deterministic function or algorithm that is dependent on not your application state, but some other external state, which will also perhaps create some difficulties when you're going to test it, or you need to adapt another strategy for how to test that. Another term, still on this with side effects, is idempotence. And let's say that a function with side effects is considered to be idempotent if it changes some side effect once, but the next time I call it, it doesn't change the side effect anything more. So the side effect remains the same independently on how many times I have called this function. So we change the state once, but then it's the same state. So if I have that, I have an idempotent function. And yeah, it might be a bit easier to unit test an idempotent function than to test a function that is always changing the application states. So small differences, but could be good to know. And if you manage to keep these differences in your head, okay, I'm writing a pure function, I'm writing an idempotent function here, I'm doing a deterministic logarithm, you will also sort of start to categorize your functions methods, and you will also know how much time and effort it will take you to test them. So it's a good path we are starting, path to learn how to become better programmers and write better code, testable code, better code. So all about this with unit tests and side effects. Try to be cautious with side effects. Yeah, maybe you can't avoid them, but still, try to be cautious, because it's easier to test your software when you have no or limited side effects. It's easier to test, it's easier to debug, and it can also be easier to understand and read the code when you do not have too much of side effects. It's easier to understand what actually happens in your application when you limit, narrow down the side effects happening. Object orientation, that is a programming model that is having sort of a stateful programming model. So we have states. In a class we have member variables that is sort of containing the object state. And that is how it is. So we can't sort of avoid that. So a lot of these pure functions come from the functional programming model, where we are having a stateless programming model. The application does not, in general, have a state. We are mainly focusing on functions returning a value without changing a state. So depending on the programming model we are using, that might affect how we sort of need to write our unit tests. I'm going to mention just a quick note on this is more terms related to testing and unit testing in general. So what about false positives and false negatives? Well, false positive, that would be that a test fails, but there was no error. So the test fails for some reason. But when I look at the code, well, no, it is not an error. It was the faulty test that failed. That would be a false positive. A false negative, that would be that the test passes, but there were no error. So the test failed to show off that there actually was a problem in my software. So that is about false positive and false negatives. And if we just bunch them together, it's all about showing that something is wrong when there isn't, or failure to show that something is wrong when there is. We can take one more example on this false positives and negatives. That false positive, that should be, let's say I'm gonna see if I'm sick, so I take a test for it. And false positive here would indicate the presence, I am sick. So false positive would say, you are sick, Michael. But really I am not. I wasn't sick. So that would be a false positive there. And the false negative there, that would be taking the same test. I'm feeling a bit sick. Is I'm really sick? And the test says, no, you're good to go, Michael. But I was really, really sick. So that would be a false negative. So false positives, false negatives. Just remember, it's about failure in the test process in some sense. So there we have it. It's a summary of these, well, the side effect part of this lecture. So we have side effects, and we have talked about how it affects how we write our code and what type of testing code we need to write. We talked about referential transparency, which could be achieved by doing only pure functions. We talked about deterministic and non-deterministic algorithms dependent on some external date and time. We talked about idempotence, it is not the pure function, but it only changes the state once. And if I call it many times, the state remains the same. And then about false positives and false negatives. So, what do we think about industry matters here? Do we do unit testing out in the industry? Well, as always, it depends. Depends on what type of organization we have, its maturity, its size. Is it consulting or is it product developing? I would say that many well-organized companies that do product development in general have applied unit testing as a good part of their testing process to sort of produce high quality product. But independently on what company you're working, maybe they don't do unit testing because they don't see the need for it. But I think that very many skilled programmers sort of adapt and have unit testing as part of their sort of toolbox. So even if the current project I'm working in doesn't sort of say we do unit testing, but maybe I do it for my own sake because I'm trained at doing it, and I know that it will basically help me develop my program, help me debug it. It's a good thing. So I think some skilled programmers, independently of the organization's focus, will do it with their code, if time and project allows for it. Always depends on. And what do researchers do here? So what about research matters? I just took up here a couple of research papers written last year just to get a feeling of it. But in general, the test area, and specifically unit test area, is sort of a process that is very researchable. And the metrics coming out from this unit test method, unit test process, could also always be sort of collecting metrics, analyze them, and talking about how could we improve this? Can we earn money of this? Can we produce better software, happier customers, earn more money? And when we have this type of area, yes, it's very, very researchable from an academic point of view. So there's just a couple of sort of titles from late published papers in unit testing. And I think that was all for now. We have walked through a slide composition talking a lot about unit testing and the arguments on why we should do it, and perhaps what we hope to achieve by becoming good at doing unit tests. And we have also talked a bit about this effects of unit testing. When we start doing unit testing, will that really, I would say yes, change our mind on how we write our code and programs? Yeah, because we want to write more testable code. And testable code has fewer side effects. It has limited connections to other units. It is easier to test. So is it really better code or good code? I would say good code at least. And I would argue, yeah, I think we get better code when we produce this type of testable code. So in my sense, yeah, doing unit test is a good way of sort of improving my skill set as a programmer. So that was all for today. So have a nice one, and I see you shortly with a new topic. Bye bye.